In a tournament there are 6 teams that play each other twice. A team earns 3 points for a win, 1 point for a draw, and 0 points for a loss. After all the games are played, the top 3 teams earn the same number of total points. What is the greatest possible number of total points for each of the top 3 teams? You can pause here and solve the problem before seeing the solution. Let's start by counting games. There are 6 teams, and each team plays every one of the other 5 teams twice. That means each team plays 10 games in total. To make the top 3 teams score as high as possible, we want them to win as many games as we can. First, look at the games between a top team and a bottom team. Let each of the 3 top teams win both of its games against each of the 3 bottom teams. That is 6 wins for each top team. And 6 wins times 3 points is 18 points. All 3 top teams can do this at the same time, since these games are only against the bottom teams. Now the top 3 teams also play each other. Each top team plays the other 2 top teams twice. So 4 of these games. A decisive game hands out 3 points. A win plus a loss. While a draw only hands out 2 points. 1 plus 1. So to earn more, we want these games to be decisive, not draws. We can arrange them symmetrically so each top team wins 2 and loses 2 of its 4 games against the other top teams. That is 2 wins times 3 points, which is 6 more points each. Adding it up, each top team earns 18 points from the bottom teams plus 6 points from the other top teams, for a total of 24 points. And because the intra-top wins are shared evenly, all 3 top teams tie at 24. So the greatest possible number of points for each of the top 3 teams is 24. That is answer choice C.